Hi, my name is Marlo Studley. I am a senior solutions engineer at Sumo Logic. I'll be walking you through Sumo's application observability solution. We'll set the stage here for the in-platform demo. We have an online application that supports our digital business. It's called Sumo Coffee. Sumo Coffee has a front-end application running on AWS with app components like DynamoDB and platform technology running on Kubernetes, Lambda, and EC2. We have our front end where our customer orders coffee and the back end of microservices that provide all the necessary functions to fulfill the order. Every now and then, the application encounters issues we need to troubleshoot. The demo scenario simulates an upgrade deployment of a new microservice version with a bug that starts consuming too much CPU and memory. This upgrade causes delayed response times that move up the chain and eventually impact the end user experience. Let's jump into Slack to see an alert about this issue. We can see an alert webhook indicating that the coffee preparation time has increased. The trigger condition notes that 95% of the latency is greater than the threshold in the last 5 minutes. Let's click on the alert URL to bring me to the Sumo alert response page. First, we see the query where the business metric is parsed from the log data and used to trigger the alert. Then we can easily see when the monitored metric was way above the configured threshold. Interestingly, the spike correlates with other alerts that were fired at the same time on the out-of-the-box APM latency metric. If I scroll down, we can also see an anomaly in CPU usage for the coffee machine service Kubernetes deployment, which explains the latency increase for coffee preparation. Our AI also found and correlated a new log message signature about a stuck thread due to bad file handling that explains why the CPU was overutilized. Fortunately, this issue was resolved. But the big takeaway from this view is that Sumo consolidates all relevant alert data in one place. You can see when the metric exceeded the defined threshold and how long it was out of compliance. You can see those associated log messages down here, alerts, and we can check out our playbook all from one location. With all this information centralized, you can decrease MTTR and alert fatigue. Let's use the playbook to understand how Sumo gathers data and determines conclusions. Sumo Logic monitors your whole application stack, your business KPIs, end user experience via browser implementations, APM metrics via automatic code instrumentation, as well as container and cloud infrastructure. Our stack is running on Kubernetes in AWS, as you can see in the third row of key service KPIs critical to this environment. In the real-time user monitoring page load times panel, we do see some spikes. To investigate, I'll click into that spike. If I click into the spike and then go into the entities panel, I can open up this application data in the entities dashboard to dive into more detail. Real user monitoring, or RUM, allows you to easily detect poor user experience and resolve issues with context from across the stack. The data in this RUM dashboard comes directly from the user's browser to represent KPIs like page load and painting times, browser type, operating systems, and geolocation. Here, I notice a spike in website performance, as well as paint times. To further investigate, let's check out the back end of the application by navigating to the Application Health Services Across Services dashboard. Now we can investigate via our APM metrics. I can see the service dependencies in the application service map. And down here, I noticed the latency spikes for some of our services, including the coffee machine service. We can conclude that coffee machine service was the problem based on these views, but let's look for some more tangible evidence. In here, I'm going to click into my entities and open this service directly in traces. Now in the traces view, we're looking at all of the transaction traces for the coffee machine for the time period of the initial spike. I can sort the duration column to find the longest running traces broken down by services. If I hover over the duration breakdown, I can see this is another confirmation that the coffee machine service is the problem. Let's drill into this transaction. Here we can clearly see the maroon service contributes the most to the latency. So we'll inspect this last call in detail. Sumo provides contextual navigation in this side panel to easily jump between logs, metrics, and traces for diagnosing between the various layers of application and infrastructure. Here we see a summary of the span. The metadata tab automatically presents information related to your whole infrastructure stack for this particular call. And in our entities tab, we see alerts on application and namespace levels. We also see that this deployment only runs one pod. And let's check out infrastructure KPI for this Kubernetes pod that executed this call. I'll go ahead and open this in the entity dashboard. Sumo Logic automatically collects all Kubernetes logs, events, and metrics to present a comprehensive view of any potential issues. This is just one of many views you can use to understand the application infrastructure health. Note here, we didn't have any critical event or spike in the pod state chart. The status was the same throughout the problem timeframe. However, if I scroll down, we can see the CPU usage increased significantly and hit the limit at the same time we received the alert in Slack. I can click this spike to see the original container logs for more information. From the container, I'll open this in the log search. And in Sumo, logs are automatically collected from all containers and enriched with metadata. We can see our raw logs here. There are 179 log messages. So in order to quickly sift through those messages, we'll employ Sumo Logic's log reduce to group similar messages together into patterns. What I can see here is that one of the top errors was one of the top log messages was an error for a stuck thread. And that's going to point us to that original root cause of the problem. And if I go further down, I can see that there was an upgrade initiated by Joe at sumocoffee.com, which likely changed the environment and caused the error. To confirm that these are new activities or new log messages, I'm going to run Sumo Logic's log compare, which is going to compare those same logs to 2 hours ago to tell me whether these were happening before or not. We'll see here at the top that this error, stuck thread error here, is indeed new. And if I go to my next page, I will see that the upgrade initiated by Joe was also new. This gives us just a little bit more context to provide our team during this investigation process. We've been able to find that root cause and guide you through the depth and breadth of data collected out of the box, as well as different visualizations allowing you to observe your digital business and application stack in an effective way. Now, this includes our investigation and in-platform demo.